Hey guys, so this is a brief video on 2.3 homework. Actually, it may not be as brief as I would like it to be. And it's because it's going to cover 2.3 homework, some of it, just to get you started. And then the lesson after that, which is 2.4, the parts that we have not or did not have an opportunity to finish. And some of the homework of 2.4. So some of you may already know how to do 2.3 homework number 1, but I'm gonna go over it anyway, and just to make sure that everybody has this information. The question says complete the table for each function using the given domain, then graph the function using the ordered pairs from the table. So we have two things. We have complete the table, and therefore they're asking you to make a table, and then graph. So when the information is presented in this format, you have a function for number 1, f of x equals 1/2 multiplied by 4 to the x. And remember, I prefer that b, which is basically your growth or decay factor, in this case 4, to be in parentheses. Here you're given the domain. You're given the domain, which is -2, -1, 0, 1, 2. So technically, if we want to convert this to a table, your table is going to look something like this. This would be your table of values. And in your table, you're going to have 5 values. And they are from least to greatest for x. And then their corresponding y values. So how do I find the y values, right? For -2, for x equals -2. So remember, these are discrete values here, right? -2, -1, 0, 1, 2, and they're in braces, right? This is a brace here, and this is another brace. So to find that, I'm looking for f of -2. I want the x value to be -2. Therefore, this becomes 1/2 multiplied by 4 to the -2. And if you recall, we said in class that a negative exponent is a fraction. So 4 to the -2 is 1/4 squared. And 4 squared is 16. So this is 1/2 times 1/16. Remember, the 16 is in the denominator because the 4 squared is in the denominator. So now all we have to do is just multiply the tops here. 1 times 1 is 1. 2 multiplied by 16 is 32. So for -2, I get 1/32. Now I can do it in two different ways. I can plug in for -1 and find using the equation f of -1 and so on. Or by looking at the function itself here, I could tell that a is 1/2, that's the starting value or initial value, and b, which is the growth factor here because it's greater than 1, it's 4. Meaning that every number after 1/32 is going to be multiplied by 4. And how do you multiply that by 4? So you can do it in two ways. If you take 1/32 and multiply it by 4, which is 4/1, you can see that the 4 goes into 32 8 times. So basically you have 1 left on top for both fractions. 1 times 1 is 1. And then the denominator, you just have 8 times 1, which is 8. So this becomes 1/8. Okay. If you don't want to do it this way, you can use the equation. You can say f of -1 equals 1/2 multiplied by 4 to the -1. And 4 to the -1, we know that's 1/4, or 1/4 to the first power. And 1/2 times 1/4 is what? 1/8. Exactly the same answer. And so on. But you can keep doing this. You can multiply by 4. 1/8 times multiplied by 4 is 1/2. And then, and also remember 0, 1/2, that's your initial value. So it's right there. That's to confirm it. And then 1 multiplied by 4 again, half of 4 is 2. And then multiply by 4 again, you get 8. So you can do it either by following the pattern or plugging in f of -2, f of -1, f of 0, f of 1, f of 2. Okay, so either way. So this is basically, these are the corresponding y values for the given x values here. That was the first part, complete the table. And then this is a graph. So graphing, you have to be careful. For 2, we have, I'm going to start from largest to lowest. 2 is 8, which is right here. 1 is 2, which is right here. 0 is 1/2, which is right here. Because on the y-axis, you're going by 1 units. -1, 1 left, 1/8. So that's pretty close to here. And then even closer to 0 is -2. -2 will give you 1/32, which is even lower. So you really have an exponential function that gets close to the x-axis, okay, but never crosses it, okay? This arrow here is not to say it crosses it, it just says, just to say that it gets closer to the x-axis. It approaches the x-axis. And then it says, then graph weighted, okay? Now make sure these points are carefully plotted, especially on the quiz or test, because we want them to be as accurate as possible. Now, 1/32, you will not have an accurate value there, but try your best to show that it's lower than the x equals -1, right? Because x equals -1 gave us 1/8, and x equals -2 will give us 1/32, which is a lesser value. So that's pretty much the first question. The second question, for number 2, we're doing the same thing. Okay. And by the way, when they say using the ordered pairs, these are the ordered pairs, right? These are x comma y. That's what these are. So second question, f of x equals 9 multiplied by 1/3 to the x power. And we're given here the domain. The domain is what? The domain is 0, 1, 2, 3, 4, 5. So they switched up the domain a little bit. So again, you can make a table of values. And you can try one number and find the rest of the numbers either by plugging it into the equation or actually from the from b, which is in this case is 1/3, right? B is 1/3 here. This is x, this is y. 1, 0, 1, 2, 3, 4, and one more, 5. Okay, so we can plug in. We can plug in any value you want. You can plug in, let's say 1. You get f of 1. Remember, for when you plug in 1 for x, you get f of 1 is 9 multiplied by 1/3 to the first power, which is 9 multiplied by 1/3. And 1/3 of 9 is 3. So 9 gives us 3. Sorry, 9. No, not 9. 1 gives us 3. I don't know why I said 9. 1 gives us 3, right? 1 for x gives us 3 for y. 0, we know for 0 we'll get the a. Always, but let's double check on that, right? F of 0 is 9 multiplied by 1/3 to the 0 power. 1/3 to the 0, we talked about this in class. This part here is just 1. So this is 9 times 1, which is 9. And again, it confirms what? It confirms this to be the initial value, the 9. Now notice the rate of the rate here, the growth rate, or here actually it's a decay rate because it's 1/3, which is less than 1. We're saying from 9 to 3, we're multiplying by 1/3, which means next we're going to multiply by 1/3 again. So you can do this by hand here instead of going and plugging into the equation. So this means this number is 1. 3 multiplied by 1/3 is 1. Then if I keep going multiplying by 1/3, 1 times 1/3 is 1/3. And the next number, let me clean this up a little bit. This is going to be 1/3. The value after is going to be what? 1/9. The value after is going to be 1/27. So you're, in a way, when you multiply by 1/3, you're multiplying the denominator by 3, right? You had a 3, then a 9, then a 27. So that's how it works. Now, if you want to try it, you can feel free to try it here. You can say f of 5, let's say, just to confirm. It's 9 multiplied by 1/3 to the 5th power, which is 9 times. 1/3 to the 5th power is 1/3 times 1/3 times 1/3 times 1/3 times 1/3, 5 times, which is 1/243, I believe. And 9 goes into 243. This is 9, which is 9/1. This goes into that 27 times. Oops, sorry, that's in the denominator. So you'll have 1 on top, and this goes into this 27 times. You get 1/27, which confirms my value from the table. And then graph it real quick. So 0, 9, 0, 9, we know it starts up here, and it's an exponential decay because b is 1/3. Here a is 9, and b, the factor, it's a decay factor because it's between 0 and 1. So it starts at 9, and then you cut it in thirds, basically. So for 1, you get 3, right here. For 2, you get a 1, which is right here. For 3, you get 1/3, which is right here. And so on, right? The numbers decrease significantly here, exponentially. Oops, sorry. So you'll have something like this. And if we go back -1, you'll have one value way up here, somewhere way up, right? So I cannot graph to the left, but I try my best. Something like this. Remember, these are smooth curves, right? They're smooth curves normally. Get close to the x-axis, but never crosses it. And we talked about the idea of asymptote in the class, right? In class last time. So these are two examples that would help you get moving with your homework for 2.3. So let's move on to the next topic here, which is, let's maybe do one more problem. So number 5, it says write an equation for each function. For 5, it says it's word problem. A recent trend in advertising is viral marketing. The goal is to convince viewers to share an amusing advertisement by email or social networking. Imagine that the video is sent to 100 people on day 1. So on day 1, if here we have the day number, and here if we have the number of people or people, on day 1, you have 100 people. Each person agrees to send the video to 5 people the next day. So on day 2, if each one of these 100 sends it to 5, we have times 5, which is 500. So from here to here, you're multiplying by 5, basically. And then to request that each of those people send it to 5. So there's a times 5 and multiply by 5 pattern the day after they receive it. The number of viewers V of n, so remember we know, say, f of x or g of x. Here V for viewers, V of n, is an exponential. So V of n is going to be an exponential, and it's a function of the number of days, right? So instead of calling it AB to the x, we call it AB to the n, because it's V of n instead of V of x. So what are the values? What are A? What is A and what is B? A is the initial value. You may say it's 100, but that's incorrect. The initial value is gotten when the x value is 0. So if I were to go backwards, from 1 to 0, right? What would my number be? Moving forward, I multiply by 5. Going back, we're multiplying by 1/5, going this way, which is technically divided by 5, right? But we remember we said we agreed to multiply either by a number or by a fraction. So go back from 100, multiply by 1/5, that's going to be 20. And that's the A. So here, V of n equals A, which is the starting number, it's 20, multiplied by the growth factor here is 5 to the n power. Okay, so this is the equation of that gives you the number of viewers. The number of viewers V of n. Okay. Let's see what else they said. The number of viewers, okay. The number of viewers is an exponential function of the number of days, okay. They did not ask us to write anything, right, did they? The goal is to convince viewers, each person, okay. So this probably like write the equation. Right? This is the equation anyway. That's for number 5. Okay, number 9, real quick. Number 9 asks to write an equation for the function that includes the points. Now, if this was not in the context of exponential, you may try to see if it's linear or exponential. But in this case, I mean, we're assuming it to be exponential, right? Because I don't want people to automatically think, oh, is it y2 minus y1 e over x2? Is it linear or is it exponential? In the context of this unit, or at least this lesson, we're dealing with exponential. So it most likely is, right? Now, what can we do here? You can think about it visually, and you can say, okay, if 2 for x gives me 100 for y, 3 for x gives me what? 1000. So we can see that it gets multiplied by 10, right? From 100 to 1000. So most likely this is an exponential pattern. Now, did they say that? They said write an equation. So we don't know. It could have been add 900 and 900, and then add 900, right? Some people may argue that, oh, what if this was the x value was sorry, the x value was 2. For that corresponded the y value 100. And then for the x value 3, we got 1,000. And from 100 to 1,000, what happened? We add 900. Yeah, you can say I'm adding 900, I'm adding 900 every time, right? That would not be problematic. That's why they said write an equation. If they said write an exponential function, they're already telling you it is the first one, right? This one here, y equals ab to the x. So either way, how do I write an exponential? I know the growth is by 10. You're multiplying by 10. So 100, 1,000, 10,000, etc. And if I go backwards, I would be multiplying by 1/10, going back, aka dividing by 10, right? That's what multiplying by 1/10 is, dividing by 10. So this would be here. If I go back, I'll get 1 and 10, and divide by 10, I'll get 0 and 1. So 0 gives me 1, and that's my a. So it's y equals 1 multiplied by 10 to the x, or just 10 to the x, 10 to the first, 10 to the second. You can see here that if you have 2, you get 100, which is 10 to the second, 10 squared. This is 10 squared. This is 10 cubed, 10 to the x, 10 to the fourth, 10,000. Or 1 multiplied by 10 to the x. So if it's linear, what if it was linear? What if you decided for it to be linear? Then you can say y2 minus y1. You can do 1,000 minus 100, y2 minus y1 over x2 minus x1. So you get 900 over 1, which is 900. And then if you were to go backwards, you're taking away 900 this way. So this would be negative 800 for 1. And negative 900 more on top of that would be negative 1,700. So now you can do mx plus b, y equals 900x mx. This is m. And then plus b, which is minus 1,700. So again, because they said write an equation, they did not specify, is it linear, is it exponential? It could be either one, right? So hopefully you can pause here and kind of revisit this concept. Let's move on to the next page, which is a lesson. Okay, 2-4. In class, we did at least the first 2 pages. Now I'm going to move on to the third page here. Which, let's see if I can put it up here. Okay, almost. So for this one, it says, remember you have different representations. You have a table, a graph, a verbal description, or an equation and rule. In this case, they chose to complete some values in the table. So that's where we start, right? We start with the table. So the table says, for negative 2, you have 20. For x equals negative 1, you get 10, and so on. Notice that my numbers are gonna be halved from 20 to 10, that's multiplied by 1/2. From 10 to 5, that's multiplied by 1/2. Which means from 5 to the next number is going to be multiplied by 1/2. So that's 5 halves. Then how do you multiply by half again? Multiplying by half again, think about it this way. You have 5 halves, and you're multiplying it by half. That's like multiplying the 2 in the denominator by another 2. That should be 5/4. So this is 5/4. And then you're multiplying that by half. So it's going to be 5/8. And then what, 5/16. And then 5/16, and then 5/30. So to show your work, you can do it in different ways. You can say 20 multiplied by 1/2 is 10. Or actually, this came from the one before that. This was 40. And this was 40 multiplied by 1/2. Because if we go back here, this would be 40, the one before that, or negative 1. And then 20 multiplied by 1/2 is 10. And then 10 multiplied by 1/2. And you can complete this, right, in this pattern. Verbal description, describe the pattern shown in the table in complete sentences. Keep in mind, if you were to cover up the table, would your description be enough for another person to fill in all of the values? So you can describe it in different ways. And I liked that some of you suggested like word problem description. So some, instead of just going with, oh, we can do that. We can say we start at 5. or we start at 0, 5, right? Because that's your initial value. And then, or you can say and as x increases by 1. So from this point here, you started here, and then as x goes up by 1, the y value is what? From 5 to 5/2, it's getting half. Is multiplied by 1/2, or is half, right? That's pretty much it. Now you can do it in word problem. You can say Johnny started with $5 and his money got cut in half, right? As every hour or every minute, right? You can use that. Now equation, we already know this. I like to write the equation in function notation, so let's call it f of x. Actually, they called it h, so let's keep with h. H of x equals a times b to the x. A is this number, 5, that's a. So a is 5, and b is the 1/2 jumps. So multiply by 1/2 to the x. Interval of increasing, decreasing, we need to graph it for us to be able to know the rest of the stuff. So we need to graph this stuff. At -2, if I go here by -1, -2, and so on, and here the highest value is 20, so maybe I would go 5, 10, 15, maybe less, 20. So I hope my scale is good. 1, 2, 3. Yeah, I think my scale is fine. So I went to 20. So -2, 2 left. This is by 1, 0. Okay, this is -2. -2, 20, which is up here. -1, 10. Uh, 0, 5, which is right here. Let me use a different color. And then 1 is 5/2, which is 2.5. So this is 1, 2.5 is halfway. I decided to go every 3, I call them 5, okay? 2.5 will be like halfway right here. And so on and so forth. Then 5/4 is 1 1/4, etc. Right? And so on and so forth. So you could see that the values are going decreasing on. I always have trouble graphing this on. Right? So make sure you include these values, whatever they are, right? And again, it's a smooth curve. It approaches but never crosses. Something like this. Don't forget the arrow on both ends. So this is your function. It's going down, right? It's decreasing. And the reason is this 1/2, the decay, right? So interval of increasing, this graph is not increasing at all. You can say h of x, let's go back to h of x. Let me use the blue color. H of x is decreasing. You want to say is decreasing on its domain. Is decreasing on its domain. How do we say that? We would say on -infinity to infinity. What you mean that as your graph goes from left to right, as your x values go from left to right, your y values are dropping, right? So from all the way from -infinity to all the way to +infinity, the intervals are intervals of x-axis, x values, right? So intervals of decreasing, it's always decreasing from from the left to the right, it's decreasing. Describe end behavior. End behavior tells you, and remember we talked about this format in class, as x goes to infinity, what's happening to the function, what's happening to h of x, and as x goes to the -infinity, which means all the way to the left, what's happening to h of x. So if I go all the way to the right, which is right here, what's happening to my graph? My graph is going close to the x-axis, which means h of x is approaching 0. And as I go all the way to the left, my graph goes all the way up, which means it approaches infinity. Equation of asymptote, again, the x-axis is asymptote, that's y equal to 0. We talked about that in class. And then h of 7 and h of -5, we can use the formula. In the formula, we can say h of 7 equals 5 multiplied by 1/2 to the 7th power. And again, you need to provide the answer in fraction, not in decimal. So you're going to do 1/2 times 1/2 times 1/2 7 times. And of course, you're allowed to use a calculator. I believe 1/2 to the 7th is 1 over 128. So this is going to be 5 over 128, if I'm not mistaken. And if you want to double check, you can go on the next one here. That's 5 over 64. And the next one is going to be 5 over. So it doesn't look like 1. 5/64. And the next one for 7 is going to be 5/128, 5 over 128. And h of -5, that's going backwards this way. So you're technically doubling the amount 3 more times. 20 becomes 40, 40 becomes 80, 80 becomes 160. And now we can try the equation. You can do 5 multiplied by 1/2 to the and -5. Now, one thing I didn't tell you about, we didn't talk much about the negative fraction. When you have a fraction and you have a negative exponent, we said if you have 2 to the -5, something like this, it's 1 over, right? 2 to the -5 is 1 over 2 to the 5th. What happens if I have a fraction, like 1/2 to the -5? How do I make it positive? The easiest way is to flip the fraction and switch the sign. So 1/2 becomes 2 over 1, and the -5 becomes 1, which is technically 2 to the 5th power. So here, 1/2 to the -5, that's going to be 5 times 2 to the 5th power. 2 to the 5th is 32, times 5 is 160. And that's exactly what you would have gotten had you gone, more left. So this here, sorry, here I put -1, that should have been -3. And -4 is going to be 80, and -5 will be 160, and that's confirmed. Okay, so keep that in mind. Do these values make sense? Yes, they do. And you can explain, you can say based on the table. This is an exponential decay, etc., etc. Okay, so as you go to the right, as x increases, what's going to happen? This is as x increases this way. dy value is decreasing because you have decay. And as x decreases, that's going the other way. The y value increases. Okay, so that's pretty much this part of the lesson, which we had not finished in class or didn't completely finish. For this one, given the value, the table of values, write the equation. So automatically, your 0 for x value is, if this is, well, we have to first test if it's linear or exponential, right? You can see here that we're multiplying by 3 every time. And that's if you did not like to go from 2/3 to 2, which is multiplied by 3. So we know it's exponential. The value when x equal to 0, the value for y, or f of x, that's your a. This is a. And the multiplier here, which is the 3, is b. So this equation is f of x equals, remember it's a times b to the x. It's 2 multiplied by, in parentheses, 3 to the x power. Okay. Graph it. Easy. It's, again, we agreed that the x-axis will most likely have 1, 2, 3, 4, right? Going by ones, basically. And you don't need to go too far by ones. Just maybe 2, 3 to the left and 3 to the right. Now the y values, however, they go in 2/3, 2, 6, 18, right? So what's the scale? What's the scale? I would say maybe 6 or maybe 2. This is 2, 4, 6, right? This is 6, 8, 10, 12, 2, 4. Trying to see if it's 6. I'll do 2, 4, 6, or if I go 6. If I go 6, the 2 is going to be, and 2/3 are going to be very small. Let's do every 3 of them is 6. How about that? Because we're doing 3 and thirds, right? So this is 6. This is 6. this is 6, and so on. And let's see if I hit the 42. Nope. It's the next one after 48. It's going to be here something off the chart. So 1, 6, which is right here, 2, 18, right here, 3, 54, way off the chart right here. And then 0, 2, which is right here, and negative 1, 2/3, which is right here. So your graph is going this way. Again, this is supposed to be a smooth curve. That shows exponential growth. Okay, I'll let you try the rest of them now that you know how to do this one. The next one here, it's from points. So when you see points automatically first, just quickly, try to understand the scale. We talked about this in class. You have 1, 2, 3, 4 parts, and the total is 8. So this has to be 2. This will be 2, 4, 6, 8. So this point is 1, 2. One of the points is 1, 2. The point after it is 2, 8. The point after it is 3, 32. And you can see the pattern. You can already see that going forward, you're multiplying by 4. So the next number is going to be 4, 4 times 32 is 128. And going back, we're dividing by 2 or multiplying by 1/4, which is 1/2, and then 1/8. Okay, so this is how you know, and automatically the equation, this is g of x, so g of x equals a times b to the x. A is 1/2, I mean. This is a right here. And b is the multiplier or the growth factor, which is 4. Okay, so I hope this was helpful up to this point. Let's see what else we have. Let me clear this. Okay, the rest is homework, which you can do on your own. You can graph from an equation. Okay. Yeah, let's try maybe a couple of the homework questions. So they're pretty much the same. Let's try number 10, right? Let's try number 10 and try to fit in here. It says state AB and the y-intercept, then graph the function and describe the end behavior. So state AB. For number 10, A, the initial value is 5. B, it's 0.6. Here it's a decay, right? It's a decay factor because it's less than 1 and greater than 0. The y-intercept is basically the initial value. It's the same thing, right? Which is also y-intercept. Y-intercept. Or the initial value, right? Describe end behavior. So let's graph it. What do you think happened here? If you're multiplying by a number less than 1, your values are going to decrease. So you know your graph is going to go down. And it gets closer to the x-axis as you go to the right. But let's try. So for 0, you get 5, which is here, about right here, I would say. For 1, you get 3, I believe. And you can make a table of values. And do 0, 1, 2, 3. 0, we said you get 5 times 0.6 to the 0 power, which is 1. 5 times that is 5. And for 1, you get 5 multiplied by 0.6, which is 3. For 2, you get 5 multiplied by 0.6 squared. 0.6 squared is 0.36. And times 5 is going to be like 1.8. I believe. Okay. So that's going to be, for 2, you get that's 1.5. 1.8 is about right here. Just be careful. This tick mark here is 1.5, right? Because this is 3. This is half of it. So, and so on. If you go backwards, -1, what should you get? So you can, if you're going this way, you're multiplied by 0.6. To go to the other way, right here by 0.6. To go the other way, you multiply by the reciprocal of 0.6, aka on a calculator you can divide by 0.6. But again, we don't want to say divide, right? We want to say multiply by, or so you can divide by 0.6, which is basically multiplying by 10/6. That's what it's going to be. It's going to be like 50 over 6, which is 8.3 repeated or so. So if you go to -1, you're going to go up here somewhere. Okay. And the idea is that this is also exponential. It's decaying, right? Okay. And did they say anything? End behavior. Describe the end. What happens then? This is end behavior. This is the right-hand side. This is end, one end. As x goes to, this is x going to infinity. And this here is x goes to what? Negative infinity. This is going to negative infinity. This is the other end. So how do we say this? We said as x goes to infinity, as x goes to the right, where is your graph going? Your graph is going, remember, is going from 5 to 3 to 1.8. So f of x, or what do we call it? Yeah, so f of x is approaching what? What is it approaching? So 5 is becoming 3, which is becoming 1.6, which is becoming, so it's getting smaller and smaller. So f of x is approaching to 0, it's getting close to 0. And then as x goes to negative infinity, as x goes all the way left, the graph goes all the way up. F of x approaches infinity. And that's pretty much it for this part. Oops, sorry. So this is that question. The rest are very similar. The negative, what it does, for those of you who don't know what negative does, it just flips the graph. So if the graph goes this way, what the negative does, it flips it about the x-axis. So your graph is going to look like this. Okay, that's what a negative does. Let's try. So for this one, I can make a table of value here. I'm going to go 0, 1, 2, -1, -2. For 0, you get -5 multiplied by 2 to the 0. For 1, you get -5 multiplied by 2 to the first. For 2, you get -5 multiplied by 2 to the second. For -1, you get -5 multiplied by 2 to -1. And for -2, you get -5 multiplied by 2 to -2. So what are the values? Just to clarify here. Okay. So what are the values? -5 multiplied by 2 to the second power. 2 to the second power is 4. This is 4 times -5 is -20. 2 to the first is 2 times 5 is -10. 2 to the 0 is 1 times -5 is -5. And so on. 2 to the -1 is 1/2 times -5 is -5 halves. 2 to the -2 is 1/4 times -5 is -5/4. And you can see the pattern without doing it mathematically in an equation. So 0 is -5. 0 is 5 down. This is 3.5, 5 down right here somewhere. 1 is 10 down. One. Sorry, 1. I meant 1, which is right here. Okay, you see here the scale, and I hope I didn't mess up on the previous scale, but here the scale is 2 tick marks on the x, right? It's not 1 tick mark. So be careful. And on the y-axis, it's 3.5 type of, like, this is, I don't know what that is. This is weird. So this should be, if this is 7, this should be 7. and this should be 7, right? So the scale is bad. The scale is very poor on this one. But it's okay, we'll figure it out. On the test or the quiz, you'll have a better scale. Yeah, so for value 2, we got negative 20. 2 is 20 down, which is about right here. That's why the graph previously did not really, move exponential. Negative 1, negative 5/2, which is about negative 2.5. It's going to be here, maybe here. Negative 2 is going to be smaller, and so on. Negative 1 actually is going to be here. I should have labeled it. This is negative 1. Which is about right here. Negative 2 will be smaller. And again, graph is decreasing exponentially. Okay. So this is pretty much what happens with negative, right? When you have a negative in front of the a, negative 5 instead of just 5. This is pretty much it for up to 2.4, including some of the homework questions. I hope this was helpful. Let me go back. I think we covered pretty much a good decent amount of information. So good luck on this. Make sure you continue studying for your upcoming quiz, which is on Tuesday for odd, if you're period 1 or 3, and on Wednesday if you're even, meaning periods 2 or 4. I hope this was helpful, and good luck.